Genetic algorithms were first proposed by John Holland. They are a class of algorithms that search for optimal solutions by simulating the process of biological evolution. Python GPLearn is a library for implementing genetic algorithms. Despite its widespread use, Python GPLearn faces two challenges in factor discovery: low performance and difficulty in handling 3D data. In today's video, we will introduce you to performing factor discovery using Shark GPLearn. Shark, launched by DolphinDB, is a high-performance automated factor discovery platform with built-in genetic algorithms. Compared with Python GPLearn, Shark GPLearn offers several significant improvements. For complex metric calculations, Shark provides GPU-accelerated genetic algorithms, achieving up to 90x speed improvement compared to CPU implementations. In addition, Shark offers a comprehensive library of financial functions for metric computation, and these metrics and expressions can seamlessly switch between CPU and GPU platforms, significantly enhancing data analysis efficiency. Let's take a look at an example of factor discovery using Shark GPLearn based on daily OHLC data. The discovery workflow includes data cleaning, model training, factor evaluation and model tuning. We select data from August 12, 2020 to June 19, 2023. After importing data, we perform preprocessing, including data type conversion and null value handling. The test dataset contains approximately 1.66 million rows, covering 3,002 stocks over 554 trading days. Training 50 factors takes approximately 9 seconds. Alphalens is a Python-based factor analysis library developed by Quant-Ready. DolphinDB has developed and integrated this module based on the same logic. By conveniently calling the built-in Alphalens module, we can quickly calculate the factor IC values for different holding periods. The following table shows the IC values for the first factor discovered. To identify more qualified factors, strategic model fine-tuning through parameter optimization is essential. Based on the model training, we conducted detailed comparative experiments on parameters such as evolution generations, parsimony coefficient, and initial program configuration, etc. After model tuning and optimized experiment, we obtained the following results. From the above example, we can see that Shark GPLearn can significantly improve the overall efficiency of various frequency factor calculation studies for users. Contact us at sales@dolphindb.com for more cases on Shark GPLearn. Subscribe to our channel for more information. That's all for today. Thanks for watching.